Right, a rocket blasts off from Earth's surface. Describe and explain how the mass and the weight change. So there are two items, two things that we're talking about. One is the mass, the other is the weight. As physics students, is mass and weight the same? Are they the same? No, okay. Which one is constant? Good. So, are we able to answer the first part of this question already? How does the mass change? Yeah, it doesn't change at all. Okay. How does the weight change then? You only have three options, increase, constant, or decrease. So it is blasting off, it's going further and further away from Earth. What happens to the weight? Who thinks it increases? It increases in weight. Who thinks it stays as a constant? And who thinks it decreases? If the weight starts to drop. Okay, majority. That is the correct answer because the gravitational field gets weaker and weaker. It's just like our magnets. The further you are, the weaker the force. So same for our gravitational force, otherwise known as weight over here. So mass is a constant. You can say it doesn't change, but the weight decreases. Since they ask you to explain, you need to tell us that the gravitational field strength decreases as it goes further away from the Earth. Sorry? It's lower in space as compared to. Okay, so there's a reason why we want to put in the phrase as you go further away from the Earth. While you are in space, you could be at any point in space, right? But the key point is as you go further away, the gravitational field strength experience is lower. Any other questions? Can you straight away tell me what is the mass already on Earth? 24. What are the units? Kilograms. You must always keep repeating. The mass, 24 kilograms. It comes with the unit. The weight, 240 newtons. So since it is in newtons, it is the same unit as force. Therefore, weight is a force. Keep repeating, reminding yourself that. So what is the weight of his equipment on the moon? Does the weight change on the moon? Does the weight change on the moon? But on Earth versus on the moon? Yes, it changes. Do we expect the weight to be lower or higher on the moon? Lower. And is there an explanation that you can give me based on these values over here? Why is the weight lower on the moon? Because the gravitational field strength is weaker on the moon. As you can see, for a 1 kg mass, for the same 1 kg mass, okay, let's say my phone, for example, weighs 1 kilogram. Has a mass of 1 kilogram. I leave it on Earth. The phone has a weight of 10 newtons. The same phone, mass 1 kilogram, I bring it onto the moon. What is the weight for 1 kilogram? How many newtons? Look at the gravitational field strength. 2. So for the same item, a constant mass, I bring on the moon, it becomes 2 newtons in weight. So in this case, the weight on Earth, 240 newtons, that tells us that the mass on Earth will be 24 kilograms, which you all were able to do. Very easy, just divided by 10. Next is the weight on the moon. We multiply it by 2 over here, because this means 2 newtons per kilogram. That's exactly what it means. For the 1 kilogram mass, it has a weight of 2 newtons on the moon. For a 1 kilogram mass, it has a weight of 10 newtons on Earth. So the answer over here will be 48 newtons as expected. Okay, moving on. Define density. So like I mentioned, all definition questions are important. Put a star because you need to memorize. It may come out. Memorize. So the density is simply mass per unit volume. So in order to study smart, we are able to write down the formula as well. SITY, density equals to. So this is the definition. What do we have? Mass. So we put on mass. The word per. Per over here is the same as divided. So we put in over. So that's a fraction divided by. In this case, we are dividing by volume. So volume. So from the definition, we can get the formula. From the formula, we can get the definition. Next. Solid X is floating between Y and Z. Which of the following is true? Okay, X is denser than Y, but less dense than Z. So we use our logic to figure it out. Quite clearly, solid X is denser than liquid Y because it is at the bottom of liquid Y. But at the same time, it is above or near the surface of liquid Z. So it must be less dense than liquid Z. So the answer is C. Now when a substance is heated, its volume, okay, we haven't exactly covered this yet, but we know that it is going to increase. But what about the mass? Okay, let's say I have a piece of metal over here. After I heat it, then it becomes bigger, it expanded. Okay, now, after it has expanded, can you tell me whether the number of molecules, the number of atoms, do they stay the same or is there an increase also? So let's talk about the number of atoms and molecules. I will use, for example, borrow this pencil case. Inside is, she's got a stationery inside, right? So we use those to represent the atoms and the molecules. So when I heat up the pencil case, when I heat this up, it will expand, right? But will the number of items inside change? No. So the number of molecules, number of atoms all stay the same. What can you tell me about the mass of this item? Stay the same. The mass stays the same. The number of objects inside are the same. It's just that the size got bigger. You understand what I'm saying? Therefore, what can you tell me about the density? Since density is mass over volume, okay, mass stays the same. But when we heat the item, the volume increases. Now use your logic, use your mathematics. Tell me what happens to the density when the numerator is the same, but the denominator gets bigger. What happens to density? Go up or go down? Not smaller, right? Because we're dividing by a bigger number. You divide by a bigger number, obviously your answer must be smaller. So how then do we describe the density? Increase or decrease? Yeah, it decreases. So because the denominator is bigger, so the density will start to drop. It decreases. Thus, its density decreases. Therefore, our answer will be B. Okay. Heavier. 1 kg of feathers or 1 kg of steel. So which is heavier? Are you sure? Why? Both of them are 1 kilogram, right? Both of them have the same mass of 1 kilogram. However, do they take up the same amount of space? Which one takes up more space? The feathers will take up more space. So the steel will take up a small amount of space, right? So probably I can hold the 1 kilogram of steel in my hand. But the 1 kilogram of feathers will be a big bag. So that's the difference between volume, mass, and density. Now, based on these two, which one has a higher density? Feathers or steel? Steel has a higher density. Okay, back to our question 4. We have object A and object B. They can have the same mass, provided the volumes are different. Just like our feathers and steel, they can have the same mass, provided the density is different. Once the density is different, mass is the same, volume must be different. So here we are only left with one option, which is C. If they are the same mass, then A has to be half the density of B. Ken? Any questions? Otherwise, we'll move on. A piece of metal is shaped into a solid sphere. Okay, I want you to highlight this word, shaped. Let us do a quick discussion. When it is shaped into a solid sphere, did the mass change? When I change the shape, did the mass change? Mass, no change, huh? Mass, constant. Okay? Now, you can treat it like a piece of Play-Doh. The mass is constant when you change the shape. Did the volume change? Let's say you have Play-Doh or it's a shell of a ball, then you flatten it out. Did the volume change? Did it take up the same amount of space? Volume. That means when we talk about volume, how can we determine the volume of an irregular shaped object? Let's say I want to determine the volume of a stone. It is irregular shape, I cannot calculate. So how do I determine its volume? Put it inside water. Then, but can I just put it inside water and know its volume? We need to find the original volume of the water. We need to measure the original volume. Put a stone inside, see how much the water level rose. Then we subtract to get the volume, right? So same thing. For a piece of plasticine, for a piece of metal, I change the shape. Does the volume change? The same piece, I put it inside the water tank. Then I see the volume rise. Did the volume change for the same piece of metal? No, it doesn't change, okay? So in this case, mass is constant, volume also constant. Okay, so a piece of metal, we understand already, is changed into a solid sphere. Now, it is cut. If it is cut into two pieces, for example, okay, you got plasticine, you roll it out into a ball, you cut it into two equal pieces. Does the mass of one piece original plasticine is separated into two? Each of these masses, are they lower than before? It is actually half, right? So original plasticine maybe 2 kilograms, separated into two equal parts, we got 1 kilogram, isn't it? What about the volume? Original plasticine, let's say it is 100 cubic centimeters. You separate it into two. What are the volumes individually? 50 cubic centimeters, 50 cubic centimeters, right? So that's what's happening. When you cut, mass decreases for each piece, then the volume also decreases for each piece. Okay? Now they say that it is half the original mass. So it is similar to my example of the plasticine separated into two equal parts. Which statement is correct? Let's look at the first one. The density of sphere is higher than the density of sheet. Now, density is equals to, what is the formula for density? Mass over volume. Yes, mass over volume. Initially, at the start, for the solid sphere, for the piece of metal, the volume didn't change, the mass didn't change. What can you tell me about the density? Compare the piece of metal to a sphere. Volume didn't change, mass didn't change, so what about the density? Never changed, no? The same numerator divided by same denominator, obviously never changed. Okay. So the density of sphere higher than density of sheet, wrong. Okay, so here we have same density. This is also same density. Okay. Now, when it is hammered into a sheet with half the original mass, did the volume also become half? Did the volume also become half? Yes. Okay, so let me give you some numbers to work with. Easier for us to work with numbers. So this is a sphere. Let's say it has a mass of 2 kg. And let's say it has a volume of, let's call it 100 cubic centimeters. Okay, this is the original sphere. What is the density? Okay, calculate quickly. Mass over volume. How much is it? 2 over? Mass over volume? 2 over? 100. So this will be 1 over 50 kilograms per cubic centimeter. This is the original density. Now I'm going to cut it into 2 equal parts. Okay, so let's just have one part over here, one half of it. So what is the mass here now? The question says it is half. So what is the mass? 1 kg. Good. What is the volume? How many cubic centimeters? 50, because it is half of a sphere. So density, Morris, what is the formula for density? What? Mass over volume. Okay, what is the mass over here? 1 over, what is the volume? 50. So 1 over 50 kilograms per cubic centimeters. What do you notice about the two densities? Are they the same? Yes, they are the same. Now, I'm going to flatten this piece of metal. I'm going to flatten it into a rectangular shape, flat. What is its mass? What is the mass of this piece? Still 1 kg. What is the volume? It is still 50 cubic centimeters. So the density is still 1 over 50 kilograms per cubic centimeter. Okay? All the same. Therefore, our answer is that the densities of the sphere and the sheet, they are the same. Material. Highlight different material. Right at the top, different densities. Since they are different materials, they'll have different densities. And right now on the side, your density equals to mass over volume. Standard. Now we need to fill in the blanks. Density for A, okay, 0.25. Mass for A, 6.75. We need to find the volume. So based on the formula, I've got density 0.25, this is for A, 0.25 equals to mass 6.75 divided by volume. My unknown is the volume. So now, we need to find out what the volume is. Your mathematics teacher will tell you how to make volume the subject. But I'll just tell you now as well. So here, because I want to make the denominator the subject, I multiply by volume on both sides. 0.25 times the volume equals to 6.75. I multiply by volume on both sides, so it stays the same. Now volume will now be equal to 6.75 divided by 0.25 to get the answer 27. If you have that correct, give yourself a tick. So for part B, we're now going to substitute in the values. Density is 19.3. So 19.3 equals to the unknown mass divided by the volume, which is 8. So in order to find the mass, we multiply by 8 on both sides. 19.3 times 8 to give us the answer of 154.4. That's part B. And now finally for part C, density. Okay, direct application. Equals to mass 40 over 16, and we get the answer to be 2.5. Can I have a show of hands who got all these calculations correct? Who got all these correct? Okay, thank you. That means your maths generally shouldn't have a problem. We are going to be using this type of these methods for physics a lot. People usually say that oil floats on water because oil weighs less than water. Is that true? Is oil, does oil have a lower weight than water? Does oil have lower weight than water? No? Why not? So prove to me that I'm wrong. I say that oil is, it weighs less than water. That means water is heavier. I feel that water is heavier than oil. Prove me wrong. How? Weigh? What do you mean? Weigh water and weigh oil, is it? But let's say I weigh, okay, you need to be a little bit more specific. So if I weigh a bottle of oil, I weigh a bottle of water, then what? See, if they have the same volume, then will they have the same weight? If I have the same volume of oil, same volume of water, will they have the same weight? Tonight, go to the supermarket with your parents, go and look for cooking oil. Okay, they sell that in 1 liter bottle, 2 liter bottle. Go and look at the volume. If they write the mass, go and read the mass. Go and look at water. Also, we'll write down the volume, 1 liter, 2 liter. If there's a mass over there, go and read it. Compare. Okay, both of them their masses will be different, although the volumes are the same. So, this part, oil weighs less than water, is definitely not correct. I can have a lot of oil and just a little bit of water. The big bucket of oil will definitely weigh more than my little bit of water, my 1 cup of water, for example. So we have to explain it in terms of weight and density. And this is what we expect to see. So please copy this down first. Over here, where it is found in our formula at the denominator, volume. I require a few pieces of information in the equation. I need 2 things in order to find the unknown volume. What are the 2 things? Density and mass. Do I have density? Yes, I have it. Okay, good. So let me use green color. Yeah, I have it. Do I have mass? What did we find out the mass was? 4.5. So I definitely can find volume. These are the workings. When I look through your work, average density. Okay? Now, since they want us to determine the average density of the alloy, I require the total mass. I require the total volume in order to get the answer. So which of these do I already have? Total mass or total volume? Do I have total mass yet? Do I have total volume? Have or don't have? Look at the first sentence of the question. Do I have the total volume? Yes, I do. What is the total volume? 100. So this one is simply replaced by 100, which is actually 80 plus 20, right? So what now is the total mass? Do you know the total mass of copper? How much copper was used? Do you know the mass of copper? But do you know the volume of copper? Yeah, 20 cubic centimeters. Now, I know that we use 20 cubic centimeters of copper, and I also know that 1 cubic centimeter of copper has a mass of 8.9 grams. So what is the mass for 20 cubic centimeters of copper? just proportion. 1 cubic centimeter, mass 8.9 gram. 20 cubic centimeter mass, 20 times 8.9. So this over here will be 20 times 8.9. But is that the only mass? There is also zinc, isn't it? So zinc being less dense, 1 cubic centimeter, 7.1 grams. What about 80 cubic centimeters? What do we do with this number and this number? Multiply them together and we add them up and we divide to get the final answer. Okay? So as such over there, all the division, you must use the division symbol.